Friends, okay, here's a video on number systems. Okay, so we're going to do changing decimals, numbers with decimals into fractions, or we're going to try at least. Okay, so let's just jump right in. Okay, so can we change rational numbers into fractions? Yes, we can. All right, so how could I change 2 into a fraction? Yeah, you just put it over 1, 2 over 1. Okay, now let's look at example 2 here. Now we've got 2 comma 3. Okay, how am I going to change that into a fraction? Alright, let's get into a good habit here. Okay, so what I want you to do, okay, is I want you to say, I want to make this equal a letter. Okay, so let's say, let x, whatever letter you want, equal 2 comma 3. Okay, so now what I want you to do is I want you to move this comma right to the end. Okay, so how many places am I going to move this comma if I want it to this end of the number, to the far right? I'm moving it 1 place. Okay, so if I'm moving this comma 1 place to the right, what am I multiplying by? I'm going to multiply this by 10. Okay, so if I multiply this side by 10, so if I say 2 comma 3 multiplied by 10, okay, we're going to get 23. Okay, can you see that the comma is now here at the end? Alright, but I can't just multiply by 10 on this one side. I need to multiply by 10 on this side. Okay, so 10 times x is just 10x. Alright, and now I want to solve for x again. I want to solve for x. Alright, how do I solve for x on this side? Okay, we just divide by 10. Can't just divide by 10 on this side. I need to divide by 10 on this side. Okay, those 10s will cancel. Okay, 10 divided by 10 is just 1. Right, and I've got x is equal to 23 over 10. Right, easy. So if you put this in your calculator, you should get this if you press S to D on your calculator. Okay, let's try example 3 together. Okay, so now I've got 2 comma 3 4. Okay, now it's not just 2 comma 3, now it's 2 comma 3 4. So again, okay, we're just going to start with let this equal a letter. So let's make it x. So let x equal 2 comma 3 4. Alright, so I want to move this comma where now? I need to move it to the very far right. I want to move it to the end here. Far right. All the way. Alright, so how many times am I going to move that comma? 1, 2. Okay, so what am I multiplying by to get this comma all the way to the end here? Multiplying by 100. Okay, if I'm moving 2 places, to make it easy for yourself, if I'm moving 2 places, 1, 2, okay, I've got 2 zeros that I'm multiplying by. Okay, over here we moved it 1 place, so I'm multiplying by 1 0. Okay, 10. Alright, so if I multiply by 100 here, alright, we're going to move this comma 1, 2, and I've got 234. Okay, do you see that? Okay, now I want to solve for x. Right, how do I solve for x? I divide by whatever's in front of x, which is 100. Okay, I can't just do it on this side, I need to do it on this side as well. Alright, and that's going to give me x, those hundreds. Okay, 100 divided by 100 is just 1x. Okay, and then 234 divided by 100 is just going to stay like that. 234 divided by 100. Okay, if you put this in your calculator, you should get to this decimal over here, 2 comma 3 4. Alright, same thing again, example 4. Okay, now we've got 2 comma 3 4 5, adding another decimal there. Alright, so first thing I do, okay, we're going to make this equal a letter. Okay, exactly the same thing, every single time. Okay, let x equal 2 comma 3 4 5. You see it's the same thing I did every single time. There's 1. Let x equal something. Again, let x equal something. Okay, now I want to move this comma where? I want to move it here. No, I want to move it right to the end. Okay, far right. Okay, so how many times am I moving that comma? 1, 2, 3. Okay, so what am I multiplying by? Yeah, 3 zeros. Good. Okay, 1,000. Alright, equals. So if I multiply by 1,000 on this side, we've got 1, 2, 3. So I've got 2, 3, 4, 5. If I multiply this by 1,000. Okay. Right. Now what do I want to do? I want to solve for x again. Okay, so if I solve for x, I want to divide by everything that's in front of x, okay, which is 1,000 there. In this case, I can't just do it on this side, I need to do it on this side as well. Okay, 1,000 divided by 1,000 is 1, 1x. Okay, you don't have to put that 1 there, I'm just showing you. Alright, and then 2, 3, 4, 5 divided by 1,000 is just 2, 3, 4, 5 divided by 1,000. Alright? Alright, so I think that simplifies. That simplifies to 469 over 200, I believe. 469 over 200. Okay, so if you put that into your calculator, okay, you should get back to there. Okay, this should also simplify. Let's just check what that simplifies to. 234 divided by 100. Yeah, that's 117 over 50. Over 50. Okay, these are the same answers. Okay, this is just a simplified version of this. Okay, nothing too complicated there. Alright, now let's see if we can do this. Okay, can we change rational numbers into fractions? Okay, so here's rational. Okay, now what's different here? What is this now? What does this mean? What does this little dot on the top of 3 mean? Okay, that just means that 3 goes on forever and ever and ever, and it keeps going forever and ever and ever. Alright, so that doesn't make me scared, doesn't make me fearful, nothing. Okay, the only problem here is now I need to find a different way of getting rid of this decimal. Why? Because in the previous examples, you see they didn't carry on forever. They stopped somewhere. Okay? They stopped somewhere. Okay, so if I move this comma, I eventually got to the end here. Okay, but now with this one, because this 3 carries on forever and ever and ever and ever and ever, how many places do I have to move that comma? I don't know. Okay, I'm going to have to move it infinity times, and I'll still not get to the end. Alright, so now we've got a little bit of an issue. Okay, but that's not going to make me scared because we don't get scared in maths. Okay, so we start off with the first thing. Okay, what do we always do? Let x equal something. Okay, we always let x equal this. Okay, so let x equal 0, 3, 3, 3, 3, 3. Doesn't matter how many times you write that. That's just to write it out. You can even leave it as with a recurring there. You don't have to do this. Okay. So now I've got a bit of an issue here. Okay. I don't know how many times I need to multiply here. Okay. So let's just try something. Let's try. So let's try if I multiply by 10. Let's see what happens. Okay. So if I multiply by 10, okay, on both sides, I've got 10x on this side. Okay, x times 10 is 10x. Okay, and if I multiply by 10 on this side, what's going to happen? I'm going to move this comma once. Okay, so I'm going to have 3, 3, 3, 3, 3, 3, forever and ever there. Okay, now, is there anything that I notice here? Okay, I'm still not quite happy. I don't know what to do next. Okay, so let's analyze here. What's happening? Okay, let's look at that decimal. Let's look at this decimal. Is there anything you notice there? Okay, they are exactly the same. Okay, this 3 carries on forever, and this 3 carries on forever. Right? The only difference is that I multiplied this one by 10. Okay, so how am I going to get rid of those decimals? There's something I can do to get rid of those decimals. What do you think? We minus them. Okay, so if I took, let's say I took this 3, 3, 3, 3, forever, and I'm minus 0,333 forever, right? What's going to happen here? Okay, those decimals are going to cancel each other out. Okay, they're going to cancel each other out, right? And I'm going to be left with 3. 3 minus 0, which is 3. Okay, but on this side, okay, we're going to have an equation here. Okay, so if I said 3,333 minus 0,33333, what was 3,33333 equal to? Equal to 10x. So I've got 10x minus, what was 0,33333 equal to? 0,33333 was equal to x minus x. Alright, so now what is 10x minus x? 9x. Okay, now let's solve for x here. Okay, divide by 9 on both sides, divide by 9 there. Okay, let's carry on here. Don't have enough space. Okay, 9 divided by 9 is 1. And we've got x equal to 3 over 9, simplified, is 1 over 3. Okay. Okay, I hope that's okay. Alright, let's look at, before we do example 6, okay, let's do example 8 here quickly. Okay, do example 8. Okay, so I see I've got another recurring decimal there. Yes, now what do those 2 dots mean? Now I've got 2 dots on top of those numbers. I've got 1 and I've got 2. Alright, so now what does that mean? That just means the 2 and the 7 are going to carry on repeating each other forever and ever. Alright, it's the same issue here. Alright, same issue. Okay, so as a rule of thumb, I want to teach you guys a little trick here quickly. Okay, I want you, firstly, we're going to start with letting x equal something. Let x equal 0,27 recurring. Okay, so here's a trick. Okay, it's going to work every single time. Okay, I want you to move this comma to the back. Okay, so whatever they give you, doesn't matter what they give you here. Okay, 0,27, okay, recurring. Okay, I want you to move this comma to the back. Okay, so like in this first example that we had, we move the comma to the back. We move this comma to the back. We move this comma to the back. Okay, so now what I want you to do the same thing. Move this comma to the back. Alright, so, but we can't do it with this one. We want to do it with a new, completely new one. Okay, so how many times am I moving this comma? 1, 2. How many times? Twice. What am I multiplying by? Yeah, 2 zeros. Alright, and what am I going to have left? I'm going to have 27. Okay, and what's my decimal? Because remember, this 27 is going to carry on forever and ever and ever. Yeah, 27, 27, forever and ever. Right, let's now let's see if the decimals look the same. Let's look at this. Let's look at this. 27, 27, 27, 27, 27, 27, 27. Are they the same decimal? Yes. So if I minus them, are they going to cancel each other out? Yes, they will. All right. So we start with the biggest one first. Okay, just for convenience sake. Okay, so we've got 100 x minus the smaller one. Okay, smaller x, which is x, equal. Okay, what was the 100x equal to? This one. 27, 2727, so on and so forth, minus, what is this x equal to? X equal to 0,2727 forever and ever. Okay, when I minus those, decimals cancel out. Alright, I've got 27 minus 0, which is just 27. 100 minus x, or 100x minus x is 99x. Alright. Right, and what do I have to do to get rid of that 99? I divide by 99 on both sides. Alright, and that's going to give you, those 99s will cancel, and I've got x on the side. Okay, I'll just move that equal sign down, nice there. Equal to, and 27 over 99 simplified is 3 over 11. Okay, so if you put this in your calculator, you should get this 0.27272727 recurring on your calculator. Okay, now let's try example 7 here quickly. Let's try this one. All right, exactly the same thing. Okay, so I see I've got 0, 5, 7. So now only the 7 is recurring. Okay, but I'm going to do exactly the same thing. Exactly the same thing. Okay, so I'm going to let x equal something. What am I letting x equal? Whatever they give me. Okay, 0, 5, 7 recurring. Okay, so what did I say? What did I say for this example here? I want to move the comma where? Always to the back. Okay, I want to move this comma straight to the back. Doesn't matter what they give me, I want to move it to the back. Alright, so I want to send him right to the back of the line. Alright, how many times is he going to move from here to here? 1, 2 times. Alright, so what am I multiplying by? Yep, 2 zeros. X. Alright, equals. If I multiply by 100 here, I've got 1, 2. Alright, so I'm going to have 57, comma. Alright, so because what is repeating here? The 5 or the 7? Just the 7. So if I move the comma here, so here's the comma, okay, and we say that 7 is going to carry on forever and ever and ever and ever. Alright, only the 7 is going to carry on. Alright, so if my comma is there, what's after this comma? A whole bunch of 7s. A whole bunch of 7s. Okay, they're going to carry on. 7, 7, 7, 7, 7. Alright, so now, let's just make this a little bit neater for you guys. You guys can see here. Okay, so let's rewrite this. 7, 7, 7, 7. Alright, so let's look at this decimal here. And let's look at this one. Are they the same? Now I've got a problem. Okay, can you see that there's a 5 there? Okay, there's no 5 in this decimal here. There's a 5 there, but it's not a decimal 5. Okay, that's a 50. Okay, I don't have comma 5, 7, 7, 7, 7. Yeah, I do. So now what? How do I get this to just be comma 7, 7, 7, 7? Okay, and this to be 7, 7, 7. How do I get them to look the same? What do I have to change in this one? What do I have to do? Look at the comma. Where must I move the comma? Yeah, I can move it here. So if I move the comma here, alright, and you see it's going to be 5, comma, 7, 7, 7, 7. So that's looking nice. Okay, so what am I multiplying by if I move the comma once? Yep, 1, 0. Okay, x, 10x. Okay, so that's going to give me 5, comma, 7, 7, 7, 7, 7, 7. Alright, so now, look at that decimal. Look at that decimal. Are they the same? Yebo. And yebo. Alright, so now, if I minus them, will they cancel out? Yes. Alright, so I'm now using this. Okay, I'm using this one. I'm not using this one. Okay, I only use this to get these two. Okay, so I'm not going to use this one. So I'm using this one. Alright, so I'm going to take the biggest x that I have. Okay, 100x minus the smaller one equals. Okay, what was 100x equal to? Yep, 57,777 forever minus, what is the 10x equal to? Yep, 5,777 forever and ever. Alright, and what is 100 minus 10? Yeah, That's 90x. Okay, these 7s are going to cancel each other out. And what is 57 minus 5? Yep, that's 52. Alright, and what must I do to get rid of that 90 in front of x? Yep, I have to divide by whatever's in front of x. Okay, so I have to divide by 90, not just on this side. I have to divide by 90 on that side as well. Okay, those 90s will cancel. X is equal to, that simplified is 26 over 45. And if you put that into your calculator, you'll get this over here, or this answer here. Okay, this is what we want to get to. You'll get 0,5777777. Alright, let's try this one over here. It's a bit of a harder example. This is why I left it for last. Alright, so let's look at this. Let me just clear all of that. Okay, and let's move this up just a little bit. Okay, so I see now I've got 8, and I've got a 1, 4, 4, and I've got dots on the 1 and the second 4. Okay, so what does that mean? I don't know what that means, so what does that mean? Okay, that just means that the 1, the 4, and the 4 are repeating. So everything from here up until here, everything in between here is going to repeat. Okay, that just means that it's going to look something like this. We've got 1, 4, 4, 1, 4, 4, forever and ever. Okay, so what do I always start with? I see they gave me something. That something has to equal x. Okay, so let x equal my something that they gave me. 8144. And there we go. And there we go. Okay, so where do I want to move this comma? I want to move it where? Right to the back. Okay, I want to send him to the back. Always. Okay, I always want to just get him to the back of whatever they gave me. Okay, so if I send that comma to the back there, what's going to happen? What am I multiplying by? 1, 2, 3, 4 zeros. Good. Okay, so I've got 1, 2, 3, 4 x. Okay, and if I move that comma to the back, what's going to happen? We've got 8, 1, 4, 4, comma. Okay, so now I want you to look at what we made x over here. Okay, so let me take these dots away. Alright, so we moved the comma here. Okay, but this 1, 4, and 4 are carrying on. 1, 4, 4, 1, 4, 4. Okay, so what's after this comma? 1, 4, 4, 1, 4, 4. Okay, so after the comma, there's still a 1, 4, 4 carrying on. They keep on going. Okay, forever and ever. Never get rid of them. Okay, now if I look here, okay, and take that comma away. Right, if I look here, look at this decimal. Look at this decimal. And look at this decimal. Are they exactly the same? No, what's different? Why are they not the same? Because there's an 8 here. Okay, so what am I going to do now? Okay, if I move this comma, where must I move it for them to look the same, for these decimals to look the same? I have to move it here. Boom. Okay, how many times am I moving it? I'm moving it once. So what am I multiplying by? Good, multiplying by 1, 0. Okay, and I'm going to have 8, comma 1, 4, 4, 1, 4, 4, and so on and so forth. Okay, now do those decimals look the same as those ones? Yes, so can they cancel? Yes, how are they going to cancel? When we subtract them. Okay, so always take the biggest one first. So we take 10,000 x minus the smaller x, which is 10x. Alright, and then we take whatever 10,000 x equaled. Okay, and we've got 8, 1, 4, 4, 1, 4, 4, 1, 4, 4 occurring. Okay, minus the smaller x, which is 10x, which equaled 8, 1, 4, 4, 144 forever and ever. Okay, those decimals will cancel each other out. Right, they're gone now. Okay, and we've got 10,000 minus 10, which is 9,990x. Right, 8,144 minus 8 is 8,136. Very good. All right. And how do I get rid of whatever's in front of x there? Yeah, I divide by whatever's in front of x. Okay, so I'm going to go divide by 9,990 on both sides. And I'm going to get x on this side. Okay, and I'm going to get 8,136 divided by 9,990, which can simplify to, okay, which can simplify to 452 over 555. Alright, you put that in your calculator, yeah, you should get back to this answer over here. Right, I hope this all makes sense. Right, so there are 4 different examples that I did here. Okay, so every time I do an example, I want you to stop the video, go see if you can find an example on your own somewhere in your textbook or in the examples that I might have given you in class, and see if you can do it by yourself. Once you've mastered it, okay, then come back to the video, watch the next example, see if you can find one similar, do it, okay, come back to the video, do the next example, and so on. Okay.